All right, we have section 2-3 today, biconditionals and definitions. Okay, so let's review some vocabulary. We're going to underline hypothesis in each statement. So, if it rains on Friday, I won't have to cut the grass on Saturday. So, the hypothesis is after the if part, if it rains on Friday. All right, if I go to sleep early tonight, then I won't be late for school tomorrow. So, hypothesis, I go to sleep early tonight. So a triangle is equilateral if it has three congruent sides. So it has three congruent sides is the hypothesis. I'll know how to write biconditionals if I can identify a hypothesis and conclusion. If I can identify a hypothesis and conclusion. All right, vocabulary. What does bi mean? Bi is a prefix meaning two. A bicycle has two wheels. Someone is bilingual who speaks two languages fluently. All right, so let's draw a line from each word in column A to its meaning in column B. So biannually is an adverb, which means it occurs every 2 years. Biathlon is a noun, which is a two-event athletic contest. Bicentennial is something that occurs every 200 years. Bicoastal is having two coasts. Biped is having 2 feet. Bipartisan is being supported by two parties. Biplane is plane with two sets of wings. And last but not least here, we have biweekly, which is occurring every 2 weeks. Okay. So what is a biconditional statement? Well, biconditional combines the P implies Q and the Q implies P in a statement that says B both implies Q, P and Q both imply each other. So we can read this double implication as P if and only if Q. And you sometimes will see this written as P like this, okay? So a ray is an angled bisector if and only if it divides an angle into two congruent angles. Okay. So what is the converse of the following true conditional? If the converse is also true, we write the statements as a biconditional. Okay. So first thing, identify the hypothesis and the conclusion. If two angles have a measure, then the angles are congruent. So the P, two angles have equal measure. The conclusion, the angles are congruent. All right, so the converse, which one represents the converse? So we just switch the order. So if two angles are congruent, then the angles have equal measure. Now write these together. So two angles have equal measure if and only if the angles are congruent. Okay, so let's try that one again. So how about two numbers are reciprocals if and only if their product is 1? So identify the P and the Q. So the P, two numbers are reciprocals. And their conclusion here, then their product is 1. So let's write the conditional. So if two numbers are reciprocals, then their product is 1. Write the conditional then. If the product, oh, let me erase this. I have a little typo going on here. So the product of two numbers is 1. then they are reciprocals. All right, so let's try some more. So if this definition of straight angle is reversible, if yes, write as a truth biconditional. So a straight angle is an angle that measures 180 degrees. Reversible means that you can reverse P and Q in the conditional. So let's write the conditional. If an angle is a straight angle, then it measures 180 degrees. So the converse, let's switch them. If an angle measures 180 degrees, then it is a straight angle. And then let's write the condition, biconditional. An angle is a straight angle if and only if it measures 180 degrees. All right, so what is a good definition? A good definition is something that's true, basically. So a square is a figure of 4 right angles. So let's write the conditional statement. Okay. If a figure is a square, then it has 4 right angles. So the converse, if a figure has 4 right angles, then it is a square. Okay. Which statement is true? The conditional, the converse, or both? Well, only the conditional is true. So, is this definition of a square a good definition? Well, no. The converse of the conditional is not true. So, to summarize, in order to be a good definition, both the conditional and the converse need to be true. If that's not true, it's not a good definition. Okay, so did we understand here? So compare and contrast which of the following statements is a better definition of a linear pair. A linear pair is a pair of supplementary angles, or a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. Well, I think the first one is not exactly a good definition, is it? So let's figure out why. So let's underline the correct numbers to complete each sentence. Figures, which ones show a linear pair? Which ones form a straight line? Figure 3. Figure which one shows supplementary angles? Well, 2 added up to be 180, and 3 adds up to be 180. Which ones show adjacent angles? Angles that are next to each other? 3 and 4. And which ones show angles with non-common sides with opposite rays? Figure 3. So underline the correct word to complete the sentence. Supplementary angles are sometimes linear pairs. So do you see how these two? Sometimes linear pairs. So a better definition, a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. And that's the end of section 2-3.